Okay, today let's talk about Codeforces Round 984, problem F. First part is description. We are given four integer L, R, I, and K. We need to find out all x that can meet x between L and R and meet the requirement x not equal k after mod 2 to power of I. We need to XOR operation for all x. So for the x not equal k modular requirement, for this requirement, it means the remainder after x modular 2 to power of I not equal k modular 2 to power of I. Actually, k is always less than 2 to power of I based on the requirement of problem. So not equal k is enough. This is the requirement. This is the description about this requirement. For the XOR part, it is a binary operation. For example, for the same two elements XOR, we can use this simple 0 XOR 0 equals 0, 1 XOR 1 equal 0, 1 0 XOR 1 equal 1, and 1 XOR 0 equal 1. This is the explanation of XOR operation. So we need find all x that can meet this requirement and XOR done. Okay, this is the description about the problem. Next part, let's talk about solution. For this part, actually we need to XOR all elements x between R and L. For this kind of problem, we also can transfer the problem to prefix R XOR prefix L minus 1. We can transfer it. So after this transformation, our problem will become how to define function prefix base. This will be our new problem, actually. Of course, include the special situation that x modular 2 to the power of I not equal k. This is the requirement of the specific problem, but it is a very common transfer. Okay. Next part, let's talk about how to definition the prefix base. Actually, we can take some example for the prefix or base. For example, the k will be 0, 1, 2, 3, 4, 5. So the prefix will be, for the 1, it will be 1, yeah. After XOR between 1 and this 2, the answer will be 3. After to do it, it will be 0. To do it before, this answer will be 1. This will be 7, 8, 9, 10, 11, 12. So for this answer, it will be 0, 8, 1, 11, 0. This will be 0, and this will be 12. So when we found some routine, that means first of all, there are always some 0 for every 4 elements. Next one, always the same. Always the same for every 4 element. So it will always will be x plus 1. That means base plus 1. Base plus 1. For the another elements, it always be 1, 1. Yeah, this is the routine we always found. Actually, we can take some explanation about this routine. For the last part, for the 3 binary bits, 1 1 0 0 0 0 0 1 0 1 0. This is 0 1 2 3 0 0 0 1 1. Yeah, for the actually we can calculate simply the XOR of first 4 elements. Always we can calculate 3 be 0. For the next part, it will be another 4 elements. It is the same with first elements, except the first binary will be 1 and the last 2 elements will be safe about first elements, because 0 0 0 1 1 0 and 1 1. So this part XOR must be 0 because this is 0. In addition, this also be 0 because there are 4 elements. So we can get the answer prefix 3 plus 4 multiply x equals 0 for every x. So we will know for every 4 elements, there always a 0. So for the next value, it always equal. Yeah, it always equal. It always, if it is equal, so for the next value, that means if x XOR x plus 1 always equal 1. Yeah, so the next value always be 1. If the last is 1, so the last elements next will be x minus 1. Yeah, this will be, because the next one always is a old value, even number, so the next one will be x plus 1. So we will get the answer. If x, we will get the answer prefix x prefix, we use another variable base equal if base minus 4 equals 3. Yeah, that means equals 3. The answer will be 0. If the base modulo 4 equal 0, it will be x. If modulo 4 equal 1, answer will be 1. Last will be it. If it is 2, for example, if it is 2, that means 6, 2, and 10. It will be actually this value is base plus 1. So this is the definition about prefix x. We will know. So the next part, let's talk about how to calculate, how to process the special situation that base modular 2 to power of I not equal k. How to we can process it. We can break this problem into two parts. For the last I binary bits, for example, I equal 4. So for the last 4 elements and first several elements, this is the binary symbol of base. So First thing is we need to calculate how many x can meet the requirement. So if the amount, that means if the amount is a even number, so we don't need to process anything. But if it is odd, we need to XOR k to the answer. So this is how we process the last for the last I binary bits. In addition, we also need to process the first several elements. So first of all, we can get the answer of first several elements. That means base divided by 2 to the power of I. So this will be the answer. This will be the meanwhile this will be the amount. This equal the amount of even. And actually it will be amount minus 1 because that means amount equal base 2 to the power of I minus plus 1 because k is not in this conclusion. Yeah, that means base 2 to the power of I equals 0. So the x will be k. It also include the amount of k, amount of x that cannot meet the requirement. This is the first part. For the first several element binary bits, we also need to find the XOR after the answer. The answer after XOR all elements. So we can use prefix base 2 to I. This will be the answer after first several binary bits do the XOR operation. We also need to multiply it by 2 to the power of I. So this is the next part we need to think to do. So in conclusion, there are 3 parts of number we need to multiply. The first will be prefix base. This is the first part. The next part will be amount of x. If it is even number, we don't need to process anything. If actually we can multiply 0. If it is an odd number, we need to XOR k. Actually, the amount equal base divided by 2 to I plus 1. This 1 means base, actually s equal k. So this is the calculation of the second part, and this will be XOR. So the last part for XOR will be prefix base divided by 2 to the power of I and multiply 2 to the power of I. So we need to XOR the third part, this 3 part, and it will be the finally answer of prefix with requirement. This will be the final answer that can meet the requirement of this problem. So the answer will be for every L and R, we need to prefix R XOR prefix with L-1. So this will be the final answer of this problem. Okay, this is all about the other solution for this problem. It is a little complex to explanation, actually, at least for me. So if you want more details about the explanation, you can reference my code below this video. Next part, or if you have any confusion, you can welcome to submit a comment. Next part, let's talk about complexity. Actually, for the term complexity, we don't need much consuming time, actually. So the term complexity is very lower. Yeah, it is very low. Actually, after I submit my code, the execution time is very small. Yeah, okay. So the low, it always be O for every query. It always be O30, because the I less than 3. So the time complexity is this range. For the space complexity is the same time. We don't need extra space. So space complexity maybe O1. This is all about this problem. If you have any confusion, welcome to submit a comment or join my Discord channel. Thanks for watching.